Hey, hello guys. I'm still working with this MOSFET amplifier, and I figure out that there is some components that are really difficult to find. So these components are the signal transistor, the 2SC2240 is kind of difficult to find, and I decided to look for the equivalent of these transistors. So far I found out that the KSC 1845 is a really close equivalent, the closest, similar to the one that I need on this circuit. Right now, here are the transistors that I need to replace with new ones. So these are kind of difficult to find. 2SC2240. So I checked online and I found out that the KSC 1845 has similar values just like the original one. The original one is okay. Let's say let's compare this. Right now, as you can see, they are almost similar. 300 milliwatts of dissipation, and this one, the bottom one, is 150, I think. So milliamp. Let me see. I do not see that. This one says 300 milliwatts. Maybe some of the other information down here. Oh, this one is 500 milliwatts. It's a little bit more, can dissipate more heat. And this is specified for audio frequency, a low noise amplifier. This is the PMP is KSA 992. It's kind of early. That's why I'm talking like this. So what I need to do right now is change all the names of the transistor that I need. It needs a new part numbers, so I need to do it. Right now I found those on Mouser. They have it. They have those available. They got a bunch of them. So this is the multi-scene simulation. I think I can just replace it to see how it's gonna respond on the simulation. And let's see, I have here, I think I can replace these. Let me see. Let me see if I can find those. So let me see. I will go to Mouser database. Okay, now I'm going to type that. Okay, let's see. There you go. Now I need to KSA. Okay, sorry about that. It's not C. It is C. 1845. There you go. I found it right here. So what I need to do is do the same thing with the other transistors. Replace those. Okay. There you go. Right here. KF. Okay, 1845. So these are the ones that I need to replace because the other ones, they are difficult to find. And I need something that is not that difficult to find. You need to be find it quickly. So there you go. All right. So now that we have the correct components, I mean, not that they were wrong. I mean like they are not available. They are there's it's not it's. Let me explain you better. If you are going to purchase the original semiconductor, you're not going to be able to find it. I don't think it's available on mouse. So let me see. 2SC2240. Let me see. 2240. I don't think it's available on obsolete. As you can see, it's obsolete, so it's not available anymore. So that's why I had to replace it with the equivalent that is a modern transistor like this one here, 1845. As you can see. So I'm going to do the same thing with the other transistors to update the schematic, And after I'm done, I will share this file with you guys, so you can make this power amplifier. So far, I made a amplifier with 8 pairs. It's complete, but I will continue checking just to make sure everything is correct, just in case. I always do that. Here on the circuit, the output, he has the protection circuit and the clipping indicator, just in case the amplifier is clipping. So this LED will light up, so to let you know that it's clipping. The circuit for the speaker protection is here, this one here. So I also will share this PDF file of the speaker protection. I think it's just DC protection, and probably 5 or 6 seconds delay for the relay to engage. So it has also the NTC 10K, so you can place it on the heat sink. So in case the amplifier gets really hot, it will shut down the relay. So I will continue here, making sure everything's correct. But I had to change all the part numbers here, so you will follow the newest. So this one here should be KSA 992. So these two, let me see, I gotta make sure everything is correct. This is 970. Okay, 970. So I need to, okay, I need to find information about that. So let me see, PMP. Okay, 2SA 970. I think the other one should be fine. Yep. Yeah, it should be fine. It should be fine. I don't need to worry about that. So I'm going to change those to make sure that. So this is PMP. Let's go to Mouser database, and I need KSA 992. There you go, right here. All right. Let's replace those. Okay, now replace those transistors with the modern type. Actually, sorry, but it's too early. Actually, I'm replacing for the transistor that are able to purchase, not transistors that are really difficult to find. Also, I found out that Q8, you can actually change it for MJE 350. I found out on the one of the schematic is different. So let me show you. I think I have it on the desktop. Let me find it for you guys. That's okay. Don't worry about that. I think I have it somewhere here. It is different. This schematic is different from the. Let me see. So I found out that you can use on QA MJE 350, and the bottom one you can use a Q7 MJE 340. So luckily this transistor, the space between them is, I have 3 millimeters, so it should be fine. It should be fine because I have, if I measure here, I got 3 millimeters. So actually you can use those here. So QA can be MJE 350, so that's why I leave it. I maybe I'm going to change this macro to make it look like the macro design for those transistors. Maybe I'm going to change this to make so you will see that, or I can just leave it like that. I'm not sure. Well, I already placed a note here that QA can be that transistor, and the leads orientation is right here. Emitter, collector, and base. So the information is right there, so you can. And this one here, the bottom one, Q7, you can be MJE 340, Q7. So and the information is here: emitter, collector, and base. So you will not be lost. You're not gonna be lost. So you'll be fine. Let me see how it's going to respond with that. Also, Q9 can be this transistor, MJE15030G, and the bottom one, that's it. That's the NPN, and the bottom one can be MJE15031G. So those you can change for those. Those are on transistors. I mean, not like they on. Also, this transistor here, I had to change it. I had to change this because on the schematic it shows that it's BC337. But I think these are not difficult to find. Let me see. I gotta make sure that they need to be uh, accessible. Accessible is the right word, I guess. All right, let's see. BC337. Let me see if I can. I think this schematic is different from the other one because I had two schematic that had different values. So I think this. Yep, I can use it. Sorry about that. It's too early, man. It is early. See, yeah, then I can use it. Yep, I can use it here. All right, so I can do that. Let me go to the simulation and replace those. Okay. Mouser database. I need the KSC. KSC. Oh, what the hell? It's not showing the. Oh, master database. No, Mouser database. There you go. All right, let's continue here. 1845. There you go. 1845. Now the other one need to be replaced by the Mouser database. I need the 992 Mouser database. All right, let's go. SA9. There you go, right there at the bottom. All right, so we got now we have new transistor that you can purchase. So a few changes on the schematic, not much. So basically only the semiconductors. All right, let's see how it's going to respond with those new accessible transistor that you can purchase. Let me save it just in case. Okay, right here. I know I'm going to increase the voltage here. Let's go with 95 volts DC. Man, it's too early, bro. It's too early, man. All right, let's see. It's coming along. I guess let's go with 120. 120 volt DC. Let's see. I guess I have to adjust the bias. Let me see. They're going to adjust the bias. Probably because I changed those the top. Let me see. It's coming along. No. So we'll go up then. That's weird. There you go. There you go. Now I'm adjusting the bias. Now it's behaving the way I want. I gotta make sure at least I have like 0.047% THD. I gotta lower that number on the simulation. I'm going to try. There you go. It's going down. Okay, 0.037. Let's see. 36, 31, 30. Okay, there you go. All right, a lot better. 0.018%. I got a, let's see. All right, I'm gonna leave it like that. 0.018% total amount distortion. Let's see how much power we can get. It's about the same thing. All right. Let me see how much current is draining. 4 amps. We got 4.8 amps of current draining that current on the circuit. So, all right, sure, it's working fine. Now I have to rename all the, or I can just go to the information here and then just type here the replacement of that transistor in particular, because you can find, I think you can find those on eBay, but it will be safer just to purchase from Mouser or a DigiKey. That should be more safer. Well, I'm going to type that the part number KSA. Okay, KSA. Did I say that right? No, C. Sorry about that. C 1845. There you go. NPN. All right, it's fine. It's fine. I'm just gonna type it here. All right. Copy. All right. So I'm going to do the same thing here. Paste it. That information here, and this one here is 2S. So the only thing I gotta do is type KSA 992 PNP. This is the PNP transistor, and the bottom one, okay, about the same. So the only thing I gotta do is just copy this information, because I will make a list of the boom of the components that are right here. I spent some time yesterday identify all the components to make sure I have the list of the components, so you can actually begin to purchase the components little bit by little bit. So here I gotta do the same thing here, paste. All right, so paste, and the other one. All right, okay, here, paste. Emitter collector base. It's all right. Cool. Right here. Yep, I need to do that. This one in the bottom one. Let me see. Power, maximum power. Let's see. 1.1. Okay. I think I can increase the voltage. It's kind of dangerous, but let me see. All right. I got 550 watts. I guess because the other day I changed this value of 33K and the negative feedback resistor. Let's just do that again. I'll make sure this. There you go. One more time. So let's see how much power we can get from this design. All right, let's see. Okay, we had 627. All right, 627 watts. Let's continue increasing the power to see before clipping how much power we can get before the clipping. We got 758 watts. We got 900 watts. one 1,000 watts, 1,000 watt at 4 ohms low, and the voltage is different. 65 volt AC from the, it's draining about 7 amps of current on one of the rail. That's pretty good. I think that's pretty good right there. So I will continue here, updating the PCB, making sure everything is correct. This PCB is quite big, and I found out that I can use a A3 paper size. I'm not sure you guys have a larger printer to print the artwork. So I figured out that the A3 paper size is the one that I need to you know, displays the artwork, so I can share these files with you guys. I mean, if you want to really make this amplifier, anyway, I will share the file, because maybe it's going to be really expensive amplifier to make, but it's good to have this file. I mean, maybe someone would like to try it out later to make this amplifier. If I had the money, I just gonna order a few, but I'm really short on money, so that's why I do not order this PCB, which is quite big. The size of the PCB is about 325 millimeters by 100 millimeters, so this is a really large PCB. And yes, I will continue here, making sure everything is correct. Let me see what else I had to do here. Yesterday I was doing some adjustments to the power MOSFETs and stuff like that. So alright guys, have a good day. I hope you like this video. Please subscribe to my channel. You like to see more stuff about audio amplifiers. And yeah, have a good day guys. It's too early, I'm sorry about that. I'm talking like this because it's too early. Alright guys, have a good day.